Hey, welcome back. Today we're going to be doing LeetCode problem 206, reverse linked list. This problem can be done two ways, either iteratively or recursively. I'm going to show you how to do it both ways. Alrighty, with that being said, let's get started. Alright, so before we get started, I'm going to go ahead and show you kind of what a linked list looks like, how to kind of console log out a linked list. We can take a look at the linked list and the data structure and really dive in to see how we can figure out where we're really at in a linked list. So with that being said, let's go ahead and read the problem statement, and then we can look at the linked list as a whole, and then I can show you a little bit of how we can console log all that stuff out. Given the head of a linked list, of a singly linked list, reverse the list and return the reversed list. So you can see here that a linked list kind of looks like an array, but it's different. It's not really an array. It's something different. Basically, why it's different is because you have a whole bunch of different nodes in this linked list. You can see here that we have 1, 2, 3, 4, and 5. You can also see that 1 is pointing to 2. 2 is pointing to 3. 3 is pointing to 4, and 4 is pointing to 5. So with each little arrow, we have a pointer to the next node. Now, here's a problem. What about before 1? Is there anything there? There's no node there. And what about after 5? Well, there's no node there either, right? They're null. You can say that anything after 5, well, that's null because we don't have a pointer there. And 1 previous to 1 is null because there's no pointer there. There's nothing there. There's no value there. So what we want to do first is we want to create a previous value. This is going to help us log out in LeetCode. LeetCode errors out when you don't have a previous value, when you don't have a head. When it's a null value, it's just going to error out. So let's go ahead and fix that problem right now. It's going to say if head does not exist, or if it's null, we're going to return previous. You can return previous or you can return head, right? What we're doing is we're returning null because head is null in this case and so is previous. So you can return either one. But for this case, we're going to go ahead and return previous. Now, the next thing that I want to show you is how to really console log out a linked list. So let's go ahead and console log out the head. Let's console log out the head.value, and let's console log out the next value, head.next.val. And you can see here we have access to that because we have a this.val and a this.next here. So let's go ahead and run that, and we're going to console log out this first example. All right, so here you can see that head is actually pointing to the whole linked list. You can see here that the whole linked list returns back. But what's the value of head? Well, the value of head isn't really the whole linked list. The value of head is actually the first node in the linked list. And what about the next value? Well, head.next.value is actually 2. So you can see here that we're actually just grabbing, different parts of this linked list by their nodes. But let's go ahead and console log out head.next. What do you think the answer is going to be? Do you think it's going to be a value, or do you think it's going to be the remaining of the linked list where the head.next.value is? Let's check it out. So I'm going to go ahead and console log out head.next. And you can see here that what we get back is actually the linked list, but where the head.next.value starts. So it's 2, 3, 4, and 5, right? So that's a little bit of how you can console log things out, how you can console log out the linked list on LeetCode, and you can really kind of dive in and check out this linked list. I also want to show you what will happen if we don't have this statement here. If we get rid of this statement and we run it, we'll see an error. It'll still console log things out, but it's a little bit different. This is not the way that we want to console things out. So let's go ahead and bring that back, and we'll run it again. And this is our default for previous, and you can see here that it allows us to play a little bit more nicely with linked lists on LeetCode. Okay, let's go ahead and solve this problem using iteration. let's go ahead and read the problem statement again. So given the head of a singly linked list, reverse the list and return the reversed list. So in the first example, we have a head and it's equal to 1, 2, 3, 4, and 5. What we want to return is actually 5, 4, 3, 2, 1. Ideally, if this was an array, we can just say, all right, array.reverse, blah, blah, blah. But that's not really what we're doing. What we're doing is, and the way to really think about this is we're actually reversing the pointer. We're wanting the pointer to look differently than what it is at the current part or the current statement. So 1 is pointing to 2, but really what we want is 2 pointing to 1. So I want you to just replay this over and over in your mind. We're actually reversing the next pointer. That's actually what's going to happen in our code. We're reversing the pointer. And what's going to end up happening is it's going to end up reversing the whole linked list for us. You can see here 1 to 2. Well, actually what's happening is the pointer is being reversed to 1. And so you get 2, 1 here instead, and that's the expected value. Now here in input 3 is we're expecting null or an empty linked list. An empty linked list is equal to null, so that's what we're going to return. So if the head is equal to null, then we're just going to return null or previous, right? The default value that we already set up. To make this a little bit easier, I'm going to go ahead and call current, and I'm going to set that equal to head, so we can kind of get an idea of where we're at in this whole thing. Okay, let's go ahead and form our iteration. So while current does not equal null, because remember what I said at the beginning, after 5, that's eventually going to hit null. And we want to do this iteration as long as we don't hit null. And what we're doing is we're going to be moving current up and up and up and up until we get to null. And we don't want this to keep running after that, right? This is our base case. As long as current does not equal null, we're going to run through this problem statement. We're going to go ahead and call a next pointer, a variable, and we're going to set that to current.next. Current.next is going to be changing throughout this iteration. So we want to make sure that we keep a value in memory called current.next. All right, the next thing that we're going to want to do is we're going to say current.next is equal to previous. Now this is where that swap is happening, because ideally current.next, this pointer is pointing to 2. But what we really wanted to do is we wanted to point to null, right? We want to reverse this linked list. And so 1 should be pointing to null instead, not 2. So current.next is equal to previous. Previous is now equal to current. And what is current? Current is 1. So 1 now is going to be pointing to, so 2 is going to be pointing to 1, and 1 is going to be pointing to null. So this is where that change is kind of happening here. All right, and then what we want to say is current is now equal to next pointer. So next pointer is actually going to be 2, right? So now we have 2, 1, and 0. That's where this iteration is happening. I'm going to go ahead and console log out previous, because in the end, this is what we want to return. We want to return previous, because previous is now set at null, and then we're adding to it as we move along. So let's go ahead and check this out. So I'm going to console log out previous and return previous. Let's go ahead and run this. All right, so here we go. Here's our output. It's the correct answer. And let's go ahead and look at our statement here. So we currently have 1 in our system, right? In our linked list. And then we have 2, 1. Then we have 3, 2, 1, 4, 3, 2, 1, and then 5, 4, 3, 2, 1. So basically what's happening is this thing is adding all the previous numbers to this linked list as we move along. I'm hoping this makes sense. I'm going to go ahead and submit it. And this is going to be our first way to solve this problem through iteration. All right, perfect. So we got our answer here. And the next way that we're going to do this is we're going to use recursion. Okay, let's go ahead and run through our recursive solution for this problem. typically in recursion, you want to have a base case where you return out of the recursive loop. So our base case is actually already set up here. If head is equal to null, we're going to return previous. Now previous is currently set to null, but as we recursively go through this problem, what's going to end up happening is we're going to return the reverse linked list, and then it's going to just loop us out of this recursive loop. Okay, the next thing that we want to do is let's go ahead and create some variables to keep track of some of the things that we want to keep track of in our problem. So the first thing that I'm going to create is a current, and I'm going to call that head. So current is the head. That's our whole entire linked list. And then we're going to keep track of our next statement. So next pointer is going to equal current.next. And current.next is changing, so that's why we're going to kind of keep track of the next pointer here in this section. And then the next thing that we're going to do is we're going to say current.next is equal to previous. So you can see here that we're already starting to change some of the things in our linked list. Our current.next is going to equal the previous statement, which is now null, right? So current.next is equal to null, and the next pointer is equal to current.next. And the last thing that we're going to want to do is we're going to return reverse list. And what we're going to put in here is going to be our next pointer. And we're going to put in our current statement. So current is now equal to head, and then the next pointer is equal to the next value, right? And we're going to continue this so on and so forth until we get our reverse linked list, because once head equals null, it points to this null value. We're going to return the linked list, the reversed linked list. Let's go ahead and run that. Okay, perfect. You can see here that we have passed all of our cases, but let's go ahead and run through this statement. So currently we have a linked list of 1, 2, 3, 4, 5, and each part is pointing to the next pointer. So as you can see here, current is actually equal to the head, which is 1, or 1, 2, 3, 4, 5. And then we have our next pointer. So our next pointer is actually current.next, which is 2, 3, 4, 5. And then what we're doing here is we're setting it to the previous. So current.next is now equal to null, right? And then what we're doing is we're calling the reverse list one more time. So we're saying next pointer 2 and current 1. So in other words, next pointer or head is going to equal to 2, 3, 4, 5, and current or previous is going to equal to 1, the value of 1. And then, so if we keep going through this problem recursively, what's going to happen is current is going to equal to 2, and then the next pointer is going to equal to 3, right? Because current.next is 3. And then current.next, we're setting that to previous, which is now 1, right? Because previous is now 1. So we're going to keep doing this iteratively until we get to recursively until we get to null. Once we hit null, like we have here, we're going to return previous, which is going to be the whole reversed linked list. Okay, hopefully that clarifies it for you. I hope you have a great day and a great rest of the week.